Hi, my name is Dear Tiagi, and in this video, I'll be going over how self-driving cars work. Before we get started, I just wanted to apologize for not posting videos in the last week. My house has been renovated, so I haven't been able to access this room. But now I can, and so here I am, back on here, posting videos. Okay, so to start, self-driving cars, how do they work? Well, first of all, how do they see? How do self-driving cars see the environment? Right, as humans, when we're driving a car, we are able to drive because we can see, our surroundings, we can see other cars, signs, etc. So the first thing is self-driving cars need to see to work. And so what environments do they have to work in? They have to work in bad weather. So bad weather can mean anything from extremely sunny, right? So if it's really sunny, sometimes it's hard for even us to see because it's glare. So sunny environments, they have to work in rain, which is also really hard because it gets darker. And speaking of darkness, they have to work in dark environments, fog, snow even. So there's a whole range of bad environments, bad weather, and even good weather that they have to work in. So that's one thing. And they also have to be quick, right? So by quick, if someone's like running on the street, if a kid just like runs on the road to get his ball, these cars have to be really quick so they can stop and prevent, you know, an accident. So they have to be quick, right? And they also have to understand like signage and traffic rules. So those are the main requirements a self-driving car has to fulfill in order to work on the road. Because that's how we function. We have to be able to work in bad weather, have to be quick, and we have to listen to the traffic rules. So the way cars do this is they use sensors to determine this information. And so the first sensors that cars use, and it's kind of obvious, is cameras. And an example of a self-driving car that uses cameras is a Tesla. And fun fact, Teslas only use cameras. They use no other sensors. And the reason why is because cameras are the cheapest way of performing this technology, but they also might not be the safest way. Anyways, cameras. So cameras, they're good because they can detect color. They can detect signage, right? So they detect color, they can detect signage using image processing algorithms and AI, and they can detect traffic lights and stuff like that. So that's why they're good. But they're also kind of bad because, again, a camera only gives you a 2D image, right? So you have no depth perception, right? So with a camera, you don't get to see how far is this object. You only get to see there's an object. And so if you don't know how far it is, it's kind of hard to make decisions based on that. Well, for Tesla, it is, and they have these algorithms and AI. But again, it's not a foolproof technology because you're having to use software to overcome a hardware limitation. So it's not a great solution. And also, cameras are bad in places with, fog, right? You can't really see if there's fog. Or if there's glare, right? So if the sun's shining really brightly and hits the camera, you're not really going to see much. And if it's rainy, right? Again, same with fog. Again, cameras are useful because you need them for color, signage, traffic lights. But again, they have their limitations here. So how do we overcome those limitations? How do we get a 3D image? Well, the way we do this in most cars, self-driving cars, is by using LiDAR. LiDAR is a technology that's used by cars like Waymo, which is this like taxi service down in California. And so how they use it, well, first of all, LiDAR stands for light detection and radaring, and ranging, sorry. And so how LiDAR works is basically you have this sensor here. And what it does is it spins. Okay, the sensor spins and it sends out a laser, which is just a light wave. And then this laser sends in all different directions, like all around. It's spinning too, so we can send it in everywhere, 360 degrees. And so this laser, this infrared light beam, what it does is it can send it off to somewhere. And if we imagine like an object here, a person or something, this laser is going to bounce off and go back to the laser where it's going to sense. The LiDAR system is going to realize, oh, we just received this light beam back. And so based on this information, it can figure out the distance. Because let's see, it goes here, here. So distance we know is equal to speed times time, right? And so to find the distance from here to this point of the laser, we have to do distance is equal to the speed of light, because infrared light goes with the speed of light, times time divided by 2. Because again, it's going 2D because it's going here and here. So divide by 2 and we get our distance. And so you can imagine if we do this for, millions and billions of trillions, I guess, of objects, of lasers around us, we're going to get a 3D image because we're doing so many little points. We're finding the distances of so many points around us in very, very short amount of time, right? We're just sending lasers, so it's short amount of time. Then we're going to get a pretty good 3D image of our surrounding. And how good, you may be asking? Well, if we had a coin, let's say we imagine a coin here, this LiDAR sensor would be able to detect that coin from as far as like 250 meters. 250 meters is a lot, but you get the idea. It's really good at detecting 3D images. And so, and so LiDAR works to 250 plus meters of range, and it's good because it can give us a 3D image. And this 3D image allows us to, perceive depth. And so why is it not used by Tesla? Well, main reason why is it's expensive and it has moving parts, right? So in order for the laser to work, you have to have a spinning laser. Now there are new technologies such as, I believe it's called integrated LiDAR or something, that make it so you don't have to spin the laser, but currently the only way you can really do it is by spinning this laser, which makes it more expensive than a camera. But this technology is really good at making depth perception. Similarly, we have ultrasonic sensors, and ultrasonic sensors function in the same way as LiDAR. So ultrasonic, except the only difference is they use sound waves. So instead of using light, they use sound waves at some frequency. And because they use sound waves, their range is much lower. Their range is about 0.1 to 5 meters, so much lower than the 250 meter range of LiDAR. And they also have low resolution because they're using sound waves, right? So it's not really that accurate. But if you're in this range, 0.1 to 5, it's fairly accurate. And so ultrasonic used to be used by Tesla. They used to use it for parking or bumper detection because it's good, again, with short distances, and it's very cheap. Ultrasonic is super duper cheap. And so they used to use it with parking and bumper detection. But now they don't really use it anymore. Again, they only use cameras now. But again, ultrasonic is another technology cars use. Similar to LiDAR, except it doesn't spin and uses sound waves. And again, there's also, they use radar, some cars. And radar, you might have heard this already, is like radio waves. And the reason why cars use radar is because it's good for tracking motion. And it's also good for low light environments. So if there's no light or it's really dark, it's also good for that too. And finally, some other sensors cars use, they use a IMU, which stands for Inertial Motion Unit, I believe. And so IMU basically tracks the acceleration and orientation of the car, right, which is helpful to know where it's going and its trajectory. And it also uses GPS, which is obviously helpful for routing and for knowing where it is on Earth. And if you want to know how GPS actually works, I do have a video, so you guys can check that out after this one. Okay, so that's all the sensors that most cars use for self-driving. And now let's talk about how they use this data to self-drive. So this sensor data, sensors, plural, right? Unless you're Tesla, then sensor data. So all the sensors data it gets fused using algorithms, sensor fusion algorithms. It gets fused into a perception model. And a perception model is basically something that, is a 3D model of the environment the car is in. And with a 3D model, the car looks for objects, so it does object detection. And it looks for, it looks at the GPS data using SLAM algorithms and tries to find out, okay, where do I want to go? What's my next step? And so by combining object detection and SLAM data, And by looking at, the signs and stuff like that, it's able to perceive its environment and say, okay, this is all the obstacles and this is where I want to go. And so once it has this perception, it then sends it to the planning module, this information. And this planning module is like, okay, well, SLAM says we need to go here. And so here's the path I should take. Here's the motion that I should have. And here's the trajectory I should take. And so the planning algorithm uses all of these and figures out all bad. And then it sends this data to the control interface. And the control interface uses control algorithms, good name, I guess, to find out, okay, how can I do this motion? How can I do this path? How can I do this trajectory with the car? How can I control it in this direction? And so once it figures out that, the control interface sends that data to the actuators, which actually, perform the action of the car. So it actually does the steering, the braking, and the acceleration. And this process happens, thousands of times per second, even more maybe. And by doing this, self-driving cars are fairly able to accurately pertain its environment and take the best course of action. But of course, there are limitations to self-driving cars. The technology is being continuously improved per day, but I do think it's a really cool technology. And yeah, thank you guys all for watching, and I'll see you guys all tomorrow. Bye.